In this concept video, we're going to be discussing the equation of an ellipse. So I'll give that to you right away here. The equation of an ellipse looks just like this. We've got x minus h quantity squared all over a squared plus y minus k squared all over b squared is equal to 1. Alternatively, we could have x minus h quantity squared all over b squared plus y minus k quantity squared all over a squared, and that will still be equal to 1. So you'll notice some similarities between the two. One of the similarities is we've got this x minus h here and this x minus h, and it's being squared. And then we've got y minus k here and a y minus k, and that quantity is being squared. So for an equation to be an ellipse, each variable has to be squared like we see here and here. The center will be at h comma k, and we also see this plus sign in the middle of each one of these. So anytime you have the variable, both of the variables being squared, and that must be the case for an ellipse, and you've got a plus sign in the middle, that will be an ellipse. If this is a minus sign, we do not have an ellipse. We have something called a hyperbola that we'll discuss in a later concept video. If you take a look at the bottom down here, we've got a squared in the bottom. So whatever value you see here, just take the square root of that value, and that'll give you a, which is the length of the semi-major axis. As a matter of fact, what I'll do is I'll write down here maybe just an example for you so you can see how this works for real. And we'll do maybe 100 here, and then we'll go, so this is just an example, and we'll do y plus maybe 3, I don't know, quantity squared, and that can be over, we'll go 49, and that'll be equal to 1. So if we take a look at this, the negative 6 here and the positive 3, we're really looking for the opposite of each one of those. So the center of this one would be at 6 comma negative 3. Let's talk about the direction or the way the major axis is orientated. So if we take a look at a squared here, a squared is always the bigger value. It's bigger than b, or b squared here. And if we look, the bigger value is underneath the term with x, or at least underneath x here. So in this case, the major axis will be left and right in the x direction. So really with these, all you have to do is take a look, and we can use our example here. We can say, all right, 100 is bigger than 49, and 100 is underneath the x value, or it's in the x term here. And so this major axis will be in the x direction, or left and right. Another way to say that, if our major axis is left and right, is that the major axis is horizontal. So anytime you have that larger value underneath the x, the major axis is going to be horizontal. For this one right here, this example, we've got the a underneath the y, and so this one, the major axis will be in the y direction, which is up and down, or we could say vertical. And that's the major difference between these two. Everything else is the same. The h and the k never change. Those are, the h is always by the x, and then the k is always by the y. Each one has to be squared. There has to be a plus sign in the middle for it to be an ellipse. But we can have different values underneath. With this example, we have a major axis that is horizontal, and the length of A is 10, making the length of the major axis actually double that. That would be 20. And the minor axis here, the semi-minor I should say, is 7, making the entire minor axis 14 in this case. There's one thing left to discuss here, and that is the equation to find the variable that's missing out of all of this stuff here that we discussed before. And that variable happens to be c. So for those of you wondering, hey, where is this c appear? It does not appear straight up in the equation. However, if we do know a squared and b squared, and you'll know that when you look at the bottoms here of your fractions, you need to know this. You need to know that c squared, so this is for finding the foci, c squared is equal to a squared minus b squared. Or if you take the square root of each side, you've got c being equal to the square root of a squared minus b squared. We don't need the negative sign right here, the plus or minus sign, C is a distance, just like A and B are distances, and so we just need to take the positive square root of these guys here. One thing to note is that A squared is always bigger than B squared, so you'll never end up with a negative underneath here. If we take one thing that's larger and subtract a smaller thing, at least in this case we're dealing with distances, we will wind up with some positive value inside here.